In this lecture, we will discuss some more basic definitions related to probability theory. So we start with the definition of event. So basically, the event is always subset of the sample space. So we can write down the definition of event. So event is uh, every subset. You can write down as every subset of a sample space is called an event. So every subset, that means suppose we have for example, we have a sample space S is equal to head and tail. So here this sample space we can make as tossing of a single coin. So tossing of a single coin. So we are tossing a single coin. So then we either we can get a head or a tail. So this is a sample space. Now, how many subsets this sample space have? So total number of subsets we can take as 2 raised to the power n. So that means here how many element is there? Two elements. So n equal to 2. So we make four subsets. So we make four subsets. So you know the set theory. So as per the definition of set theory, we can make the subsets. So total number of subset of this set is first is 5. 5 we say that the null set. Null set is subset of every set. Second is H, singleton set. Second, third is T, also singleton set. And fourth is itself. So we make the four subsets. Okay, or when you make the power set, so power set we can also make by using the subsets. So these are the four subsets of this set, set S. So set S having two elements, so we have four subsets. So every subset, that means these are four subsets. So every subset of a sample space is called an event. Phi, phi means impossible event, non-occurrence of an event. Okay. Now we say that what is the probability of getting a head? What is the probability of getting a tail? So that means getting a head or getting a tail be the event which is going to occur. So which is going to occur, so that is called an event. And we are talking about head or tail. So that means when we toss the coin. So when we toss the coin, the what is the possible outcomes? So that possible outcomes is called sample space. Okay. So we can take some more examples related to event. So the example is a single throw of dice. So sample space S is equal to 1, 2, 3, 4, 5, and 6. So dice having six spaces and numbering as 1, 2, 3, 4, 5, 6. Now, when we are going to write the event, so the event of getting a prime number, event of getting a prime number. So you know that what is the definition of prime number? So the prime number, we write down a E is equal to, so 2, 3 be the prime number and 5 be the prime number. So prime number always start from 2, 3 or 5. So a number which divisible by itself. Okay. So 2, 3, 5 is the prime number. So these are the event. Now 2, 3, 5 also belongs to the set S. So we can say that E is the subset of S. So E is the subset of S. Or in same sample space, you can take another example. Write the event E getting a odd number, getting a odd number. So odd number you can also write. So odd number is 1, 3, 5 are the odd numbers. So 1, 3, 5. So this E is also subset of S. All the element of E belongs to the set S. So these are the event, occurrence of an event. That means we are talking about the getting a head, getting a tail, getting a prime number, getting a odd number, getting a even number. So we are talking about the occurrence. And when we are talking about the possible outcomes, so that is called a sample space. Okay. So now we move to the further definition, that is impossible event. Impossible. The word is impossible, but that means the event is not occur. So let S be the sample space. S be the sample space, and null set. Null set we denoted as phi, which is subset of S, is the event called impossible event. Called impossible event. Okay, the which is not occurred. So that means which is null set. So that is called the impossible event. Okay. So how to say that this is impossible? That means when we are tossing a coin. So when we are tossing a coin, so we have the sample space head and tail, but we have taken as event E getting a number 2, tossing a coin, but getting a number 2. So which is not possible in the tossing a coin, number 2. So that's called impossible event. Okay, because tossing a coin only we can get a head or tail, but we cannot get a number 2. We can get a number 2 in a throwing of a dice. Okay, so such type of event is called impossible event, which is not possible. That is impossible event. Okay, so now we move to the next definition: mutually exclusive event. Mutually exclusive event. So for mutually exclusive event, we have two events. So we write down as two events, E1 and E2 are said to be mutually exclusive event. Mutually exclusive event if E1 intersection E2 is equal to phi. That means intersection of both element is equal to phi. So there is no common element between them. So we can write down as there is no common element between them. For example, so throwing a single dice, we have a sample space 1, 2, 3, 4, 5, and 6. Event E we consider as getting a getting an even number, getting an even number. So getting an even number, this will be 2, 4, and 6. Event E2 consider as getting an odd number, getting an odd number. So this gives us 1, 3, and 5. So we see that both the events having the different elements. So that means here E1 intersection E2 is equal to 5. So there is no common element between them. So that's why such type of events are called mutually exclusive event. Now we remember this. If E1 intersection E2 is not equal to 5, is not equal to 5, so then the event E1 and E2 are said to be compatible events. Compatible event. Okay, so you remember this. When intersection is not equal to 5, so they are compatible. That means some elements are common in E1 and E2. Now, we move to the further definition. So the further definition is independent event. Independent event. So for independent events, so same as two events E1 and E2 are said to be independent event if the occurrence of first event does not depend upon occurrence of second event. Does not depend upon occurrence of second event. For example, we toss two unvised coin. Event E1 getting a head on first coin. Event of getting a head on of first coin. Event E2 of getting a tail on second coin. So we have two different coins. Occurrence of first, that means we are tossing both the coins simultaneously. So the occurrence of first coin does not depend upon the occurrence of the second coin. So that's why they are called independent events. So that means here we can say that E1 and E2 are independent event. E1 and E2 are independent event. Now we move to the further definition, that is probability of an event. So very important definition. So this is probability of an event. Now how to calculate the probability of an event? So we define as in a random experiment. Random experiment we have already defined. In a random experiment, let S be the sample space, and E is subset of S. So then the probability of occurrence of E is defined as P equal to number of favorable outcome to occurrence E upon number of possible outcomes. So this can be written as number of favorable outcomes, that is NE, upon number of possible outcomes is NS. So PE, probability of event E, which is equal to NE upon NS. So this is very important definition for solving the problems. So we take one example. A coin is tossed once. Find the probability of getting a head. Getting a head. So here, first we make the sample space. So when we toss a single coin, so what is the sample space? So there are two possible outcomes. One is head or second is tail. Now, number of events or elements in sample space S, which is 2. So NS, number of element in S is equal to 2. Now, event E, event E, event E equal to getting a head. So we getting a head, so that means only is single element. Single element. So we see that how many element in E. So that means that is NE. NE is equal to 1. Now, so when we calculate the probability of getting a head, so that is denoted as PE. PE equal to NE upon NS. So this equal to 1 upon 2. So similarly, we can calculate for probability of getting a tail, which is also equal to 1. The sum of the probability is always equal to 1.